Now, let's talk about positioning. If we have a Cartesian plane, in a Cartesian plane, this axis is the I-axis and this axis is the J-axis. This is the positive I-axis, this is the negative I-axis. This is the positive J-axis, this is the negative J-axis. Now, if we bring a charge, let's say Q2, and we move Q2 just around and take it to a point, let's just say if this is the origin, this is 1, 2, 3. When we leave it here, this charge is actually at 3i position. So if we want to write this position, we simply say R2, which is the position of 2, equals 3i. Now, if we move Q2 to another position, let's just say 1, 2, 3, 4, 5, 6. We'll move it to this position. R2 is equal to 6j. Assuming this charge was Q1, we'll say R1 equals 6j. Assuming this charge is Q5, maybe the fifth charge in a calculation, we write it as R5 equals 6j. Now, if we move this charge to another position, let's just say from 0, 1, 2, 3, 4, 5. Now, to get the position of this charge, Q2, we simply say 1, 2, 3, 4, 5 in the negative I direction. So we say R2 equals minus 5i. So this is how we choose the position of an object. For us to solve vector equations, we need to understand positioning. Most times the positioning doesn't always come like this on a Cartesian plane. Most times it comes in different other shapes. For example, if we have a charge Q1 and another charge Q2 and a distance of 5 meters between them, if we want to give these charges positions, we could choose this place as the origin, the position of Q2 as our origin. So if we choose this place as our origin, R2 is going to be 0 because it is standing at the origin. Then Q1 will be on a position which we can write as R1 is equal to minus 5i, which means from this 0 position we move a distance of 5 in the negative I direction. So this would now be R1 equals minus 5i. Now, what if we choose this place as our origin? If we choose this place as our origin, R1 will now be 0. Then R2, which is the position of Q2, will be equal to positive 5i, which can also be written as 5i. So sometimes we see questions like this. The first thing we need to do is give the charges positioning. Once we give the charge positions, then we can solve vector equations from there. Now let's see a more complex situation. We have charge Q1, Q2, and Q3, a distance of 4 between Q1 and Q2, and a distance of 3 between Q2 and Q3. Now we could choose any of these points as our origin. Irrespective of where we choose as our origin, we can solve vector equations and get the same outcome. Now, if we choose position Q3 as our origin, then R3 will become 0. R2 will become minus 3i because you move a distance of 3 in the negative I direction from the origin to get to this position. So R2 is minus 3i. R1, it's going to be minus 7i, which means from this 0, we move a distance of 3 plus 4, which is a total distance of 7 to get to the position where Q1 is. Now, what if we choose Q2 as our origin? If we choose Q2 as our origin, R2 will be 0. R3 is going to be 3i, which means you move a distance of 3 in the positive I direction. And R1, which is position for Q1, is going to be minus 4i, which means from this origin, we move a distance of 4 meters in the negative I direction. Now, what if we choose Q1 as our origin? I believe you should know what we should get. R1 will be 0, R2 will be 4i, R3 will be 7i. So this is what we need to know about positioning.